This video is about mastering division of polynomials, and we need to remember that factorising helps us find the roots or the solutions of equations. By the way, we're only talking about roots that are real numbers, okay, or real solutions, x-intercepts that are made of real numbers here, not complex roots. And basically we've seen before that factorising is one way of doing it, and we need to throw back to what we already know, and we know that quadratics can have 0, 1 or 2 solutions or roots. Cubics, interestingly enough, must have 1 or 3 roots. So what is the technique we're going to use? We're going to use the technique of dividing one polynomial into another polynomial, and it's like the long division process. Now I find that these days that's a bit hit and miss with students, so it's not always taught in primary school and assumed as known in primary school and not taught again in high school. So long division with just regular integers, here we go. So if we have something like this, that's 274 divided by 13. Okay, so we have to find what goes together to make up 274, what multiplies together. And so we look at multiples of 13, and the closest one perhaps where we've got something in, we won't have anything in the hundreds because 13 times 100 is 1300, so we look in the tens, and the closest we can go just by looking in the tens is 20. So that's a 2 in the tens column, so that's 20 times 13 is 260. So what we do, we subtract that off, and right, what's left over down here? 14. So we're up to the units now, and obviously one lot of 13 without exceeding 14. So we have a remainder of 1. So we have 274 divided by 13 gives 21 remainder 1 by integer division. So another way of writing that would have been that 274 is made up of the following. Okay, so 274 is made up of 13 by 21 plus 1, because the remainder. Okay, so it doesn't go in exactly, there is a remainder left over. And these things have names, and this is called the dividend. That's called the remainder. Now because that's the thing doing the dividing, that 13 is the divisor. And the quotient is the 21. Dividend, divisor, quotient, remainder. Okay, now we need to apply this to polynomials. So when we're doing this, whether it's with integers or polynomials, we have something divided by something which gives us a mixture of Q and R. So in other words, we have the Q and R as the quotient and the remainder, and basically we have a dividend fitting into a divisor, and it gives us a mixture of quotient and remainder. We can rearrange that, so if we make P the dividend, D the divisor, Q the quotient, R the remainder, we can find the dividend is the multiple of the divisor and the quotient plus the remainder. And we saw that with 274. Okay? So what now if we have a couple of polynomials here? Okay, so we've got x squared plus 7x plus 11 divided by x minus 2. So we set it up like we did when we were working over here before with integers. And we've just got to do the same thing, although we probably have to think a little bit more. So if we want to multiply by x squared, this x minus 2 here will exceed x squared. So we need to look at the x column first. And if we want to get something that matches the x squared here, to eliminate it, because if you think about it, that's what we were doing with the integers, we need to multiply x minus 2 times x. That will put an x squared there and a x there. So that's been multiplied by x. There's nothing there. Okay, so the x squareds are eliminated. Be careful here, we have 7x minus negative 2x is 9x plus 11. Now we look at 9 times this here, the divisor, okay, and that will make 9 there, 9 minus 18 there, eliminates the x. 11 minus negative 18 is 29. Okay, so what we have is that this here equals, or more strictly, that there is the correct answer. Because it's clear that x minus 2 is not a factor, not actually a factor, because it doesn't go in exactly. So instead of just leaving the answer like this here, we must convert it to this answer here, okay, because technically x minus 2 is not strictly a factor. So we can write that as an interim result, but that's the true answer there. Alright, we've got our dividend on the top. Dividend, divisor, quotient, remainder. Okay, let's look at another example. And hopefully we're going to rearrange and see this result here. So again, we've got all of our parts from the dividend, okay, and that should match that down there. Okay, as you can see, because we're looking at functions, and polynomials are a function of x, okay, or a relation, or an expression involving x. So here we go. Let's look at another example. Okay, so we've got x cubed plus x squared minus 14x minus 24 divided by x plus 2. So we need to first multiply by x squared. Okay, and we yield that, so we can multiply there by x squared and subtract. We have, notice how we have a negative x squared there. Alright, and that will happen. So we bring down minus 14x from here, bring that down. We need to multiply by negative x. So x plus 2 times negative x will give this. Negative 14x minus negative 2x is plus 2. So that will add 2 in other words. So negative 14x plus 2x is negative 12x. Bring down the minus 24. We need to multiply by negative 12 here. And lo and behold, there's no remainder on this one. Okay, so therefore x cubed plus x squared minus 14x minus 24 over x plus 2 equals x squared minus x minus 12 with no remainder. Okay, division of polynomials.